Good morning, everyone. Let's get started. Does anybody else have a homework assignment that they want to turn in? Is this all of them? All right. Let's take a look at the future. So I've just collected homework 3. The next thing on your plate is Thursday we're having a quiz at the beginning of class. And that'll be related to the homeworks that you've submitted till now. So it'll include homework 2 and homework 3. I probably won't ask you any questions from homework 1. That was it? Yeah. What is your name, maybe? Maybe that's one of the questions. All right. So the next week, Sunday, we're going to meet in the computer classroom. I have to find out which rooms are available and what has Microsoft Excel available, but stay tuned for an announcement about our location for Sunday. And then on Tuesday, so a week from today, your next homework assignment is due. That's the one that you've just picked up the paper for there. Now, these are mostly book problems, but what I've done is I've provided some additional details and hints and some requests. So in some cases, I'm asking you to be sure and write a cash flow diagram, even though the problem statement doesn't specifically say that. So be sure and read these instructions because it maybe will help you and will maybe help you understand what the expectations are. Any announcement-related questions? How was the homework? Was it easy to solve based on what we'd done in the class? Yeah. I hope that you'll find that's usually the case. If you're doing the in-class exercises, and there's no reason not to, and you're following along with the lecture, and if you look through the textbook readings, because I'm always going to tell you like where we are in the book. If you thumb through that, then I think the homework assignments will come to you very easily. So, all right, let's get into it. Most of what we're doing today focuses on tables like this. And this one is for 8%. There's a similar looking table at the back of your book for 1/4%, 0.5%, 1, 2, 3, 4, I think 5, 6, 8. There's a lot of these different tables, and they're in the back of your textbook. This table actually continues. There's a few more columns to the right, but we're not going to be talking about those other columns today. We're just focusing on what these are. What you can see, besides the fact that it says this is the 8% table, is that there's rows that are corresponding to n. Now, n can mean the number of years. Usually that's how we take it. But it can also just mean the number of compounding periods. And so if you pay monthly interest and the interest is calculated monthly, and you were calculating a problem where it was 2 years, you'd need to find the row that corresponds to n equals 24. And then, the rest of these numbers is what you'd be looking at. So today in class, rather than using a formula to calculate what is the future value or what is the present value, what you'll be using instead is a ratio. Each one of these columns corresponds to a ratio. So the first one you can see is the ratio of a future amount to a present amount. And that's called a compound amount. So if your money is compounding, that means it's growing in the future. So at 8% interest, what this means is the future value is 1.08 times the present value. And so if you wanted to know if you're earning 8% interest, how does your money grow after 10 years? All you'd have to do is look at the factor for it. The factor tells you that it has grown by a factor of 2.1589. Now, you'll notice that they're only taking this. There's 5 digits there, 1, 2, 3, 4, 5. So when you use this factor in problem solving, you're only going to know 5 digits of accuracy in your calculations. And so that's plenty if you're doing something like how much does 100 dirhams grow into after 10 years? Because we usually keep track of currency to the nearest fil. And so that's 0.01 of a dirham, right? But if it was 10 million dirhams, and how does that grow after 10 years, then you wouldn't necessarily be able to express it to the nearest fil with perfect precision. So just be aware that our final answer should have the same number of significant digits as the factor that we use. But don't round off in every step. Round off one time at the end of the problem. Any questions about rounding and factors? So for the present worth, here we've only got 4 digits of precision. And the present worth function is just the ratio of the present value to the future value. So, all right, that's all I want to show you about this table. We're going to dive right into the in-class exercise. We've got 4 problems that we're going to look at today. And in the first of them, we have the following description. And what you're going to do with this description is, first of all, make a cash flow diagram, and then use the factor by flipping over the back of the paper and find the corresponding factor that lines up with this. So we're saying if you deposit $5,000 into an account that pays 8% interest per year, and it compounds every year, then the amount in the account after 10 years is closest to what? All right, so step 1, draw the cash flow diagram that summarizes this. And the elements of the cash flow diagram, remember, are directionality, where down is an outflow, up is an inflow to whoever we're writing this cash flow diagram about. And here it says a person deposits, and so the default assumption for us is let's draw this cash flow diagram from the perspective of the person. So they deposit in the present. In 10 years, they can withdraw how much? All right? So do the cash flow diagram and then calculate the amount. All right, so let's look at this first one just to make sure we're on the same track of how to use the factors and how to do cash flow drawings. Okay, so the arrow is down because they're making a deposit at year 0. I've labeled it. You don't just put the amount. For full credit, you need to put the label. So here P equals 5,000. And the future amount is an up arrow because that could be a withdrawal. You know, that's the amount in the account. So we want to know how much is there ready to be withdrawn in year 10. And so the future amount is unknown at this point because I haven't done the calculations yet. And just somewhere around the cash flow diagram, it doesn't matter if it's above the line or below the line, but somewhere I'm writing I equals 8%, just to give the idea that this future amount is due to interest accumulating at a rate of 8% per year. Now remember, for compounding, it doesn't say here that it's compounding every year, but that's what it is. Simple interest, which would mean just 8% over a 10-year period, simple interest is rare enough that the default assumption is annual compounding. So if it doesn't say anything about how frequently it's compounding, assume annual. If it says monthly, then of course you don't assume annual. Or if it says simple interest, don't assume annual. But if nothing is said about how frequently it compounds, you can just assume that it's compounding each year. So that's why we go to row 10. So here's what we do. F/P, comma, I equals 8%, comma, N equals 10%. That's how I just sort of abbreviate like the essence of the problem inside those brackets there. We're saying that we want to find the future given a present amount at 8% compounding and 10 compounding periods. So that's how to interpret that bracketed abbreviation statement. And if we look that up in the back of the book, the factor 2.1589. So finding the future amount is just as simple as multiplying the 5,000 by the factor, and you get this amount which matches C. Yes? Okay. If it says in the problem statement that it compounds monthly, then you'd need to find something different than N equals 10. But if it doesn't say anything in the problem statement about how often it compounds, you can assume annual compounding. Yeah, so what if it was monthly? What you would do is, if this was monthly compounding, N would be 120. And I, we would have to change from 8%. I would be 0.08 divided by 12. In the back of the book, I don't think there's a table for this one. But there is in the back of the book. For example, if we had a problem where I was 12%, so if it's 12% per year, 12% per year, and n equals 10 years, and you have monthly compounding, here's how you do that one. Because it's monthly compounding, you'd say n equals 10 times 1, 2, 12, so that's 120, and then I would be 0.12 divided by the number of compounding periods per year. And so then you'd go to the 1% table in the back of the book. So you'd go to 1% and then the row 120 to find the correct factor. We'll have some examples that show you that. So you will get a chance to try out how monthly compounding works, but we're not doing it today. Mm-hmm. Yeah, there are equations. These factors, they're solving equations for lots of different rows. Sometimes it's more convenient to do the equation, but some of these, it's a lot more convenient to use the factor than to solve the equation. So I'd like you to learn both approaches. I'd like you to learn how to do it with the factor, how to do it with the equation, and then next week we're going to take a look at how you do this sort of thing using the computer, solving it with Excel. All right, so let's take a look at the second problem. If you haven't already started on question 2 of the in-class exercise, a small company wants to make a single deposit now, amount unknown, so that it will have enough money to purchase a backhoe costing $50,000 5 years from now. The account will earn an interest of 10% per year, so the amount that must be deposited now is how much? So same thing as before. Start with the cash flow diagram. Be sure to put the labels on them. Be sure to indicate the interest rate near the cash flow diagram, and then solve for the correct amount of the present value deposit. Mm-hmm. Yeah.
The last year also would be the same A, or the
Same.
Be the cumulative?
It's the same.
The last cumulative?
Yep. It's just the same amount in year 5 because the one thing that we're trying to figure out is in year 0.
What about here? There is no 0, and you want the saving amount. So they would be the same, or we have a different arrow at the end?
Yeah, at the end. It'll be one big arrow at the end.
So no annual?
It is an annual, yes.
And then
And then
at 3, and then at 7 we increase it?
that's right. Future in year 7. Okay, so here's the cash flow diagram for question 2. Any questions about when we switch, whether it's the future or the present? Okay, so the future is 50,000. Interpreting these problem statements sometimes is the trickiest part, not the calculations or the cash flow diagram. All right, so it says a company wants to make a single deposit now. We don't know the amount that they're depositing now. But they want to have enough money at the end of all of the compounding so that they can buy this backhoe that costs $50,000. So they're going to spend the money from the account on the backhoe. So sometimes the perspective is a little bit tricky because this diagram is what's happening with the deposits and withdrawals of their bank, right? But as soon as they withdraw this $50,000, they're going to turn around and give it to the equipment seller. So then that's going to be another outflow. But the purchase isn't represented on this cash flow diagram. This cash flow diagram represents the deposit into the bank and the withdrawal from the bank in year 5. So F equals 50,000 because that's how much they want to have at year 5. But what we don't know is how much they need to deposit now in the present. So if we summarize it, I hope you'll get in the habit of summarizing the problems like it's shown in the brackets here. This is a very useful convention. So P/F means find the present value given a known future amount at I equals 10% interest per period and N equals 5 periods. Question in the back? No. We wouldn't have a problem where two different transactions are being represented on the same cash flow diagram, like where we're keeping track of the bank and also keeping track of the equipment seller in the same cash flow diagram. We'd have a separate cash flow diagram for that second part. Are there other questions related to number 2? All right, so problem 3 is a little more tricky because it's an annual series. Actually, maybe it's better to call it a uniform series. That eliminates some more of the confusion. If you look back to this table, the first 2 columns are called single payments, and the last 4 are called uniform series payments. So uniform series payments, instead of calling it an annual series, calling it a uniform series reinforces the fact that sometimes it may be monthly that the series is happening at. So N can just be however many periods there are. So there's 4 different combinations that's shown here because you can convert from the annual amount to a future amount, from the future to an annual, annual to present, and present to annual. All right. Before you start on those, though, I want to show you a couple of things about assumptions. So the standard notation here. Here's what we do with the uniform series when we're converting between the present and the annual. So let me show you on the cash flow diagram that the annual series part of it, or the uniform series, starts after, at the end of the first year. So the first inflow, if you think of it this way, you're making an investment in year 0 so that you'll have some equipment that you can generate revenue with in the future. Well, you don't immediately get revenue. You have to use the equipment to generate the revenue. So the logic behind having our standard notation follow this form is that you make the investment now, and after you use the equipment for a certain amount of time, you have your first inflow of money coming to you, the revenue. And every year, the revenue amount is the same. So what this illustration is showing is how much should you spend now in order to get all of this money in the future. And the types of problems you'll see that follow this cash flow style would be when someone's trying to figure out how much they can afford, how much of an investment is justified based on their future projections of cash flow. Now remember, these future amounts are just estimates. And so if you're being too optimistic in how much money you're going to get in the future, then you may overspend on the equipment today. Like if you're a paving company and you assume that your steamroller is going to be used 365 days per year, that's probably not a very realistic assumption because it takes time to mobilize the equipment and move it from job site to job site. And so there will always be downtime. So you need to keep those sorts of things in mind when you're developing your estimate of how much the revenue is going to be in the future so that you don't spend too much on whatever equipment you're thinking to invest today. So this is an illustration of P/A. And sometimes it's hard to remember which comes first, the A or the P. And in this instance, the way to interpret what's inside the brackets is find P given A. And so if we're trying to find the P value, then we'd multiply the uniform series amount, the recurring payment, we'd multiply that by the ratio of P to A, and then that would give us A. So the other way of doing problems like this is if you spend a known amount in year 0, how much should you collect every month in order to break even? Last semester, when I gave the project to students, a lot of people said they wanted to invest in real estate. How many people here are interested in owning an apartment someday, whether it's here or somewhere else? I think we all want to, the idea of being a landlord, right? That would be very nice to have someone paying you and you don't have to do anything necessarily except for maybe make sure that everything works in the apartment and cash the checks. So the question is, if you own an apartment, like if you paid 1 million dirhams for an apartment today in year 0, these sorts of problems tell you how much rent should you collect every year in order to justify your initial investment. So that's the application style of this second type of cash flow diagram. And you can see the brackets here. We're saying find the amount A given a known amount P. And then we'll multiply, we're taking into consideration the interest rate and the number of compounding periods. So I think people have already got started on problem 8.3. If not, go ahead and get started on that one, and I'll circulate around to see how your solutions are doing. All right, let's look at the answer to number 3. All right. So a chemical engineer believes that by modifying the structure of a certain water treatment polymer, his company would earn an extra $5,000 per year. So earn means it's an inflow, extra 5,000. So every year we've got 5 years of these. 1, 2, 3, 4, 5. The revenue, remember, begins at the end of the first year. So we don't draw the line up at year 0. The first time that this company is getting the money is at 1. So there's 5 payments, each of 5,000. The interest rate is 10%, so you can see here I've drawn it below the line just because that's where the space was available. When you do the cash flow diagrams, you should be sure to include the interest rate. And P equals question mark. We don't know what the present value is yet because we haven't solved it. So you can summarize this problem as shown here, P/A. Find P given A at 10% interest, N equals 5. So we go over here to the 10% table. So don't accidentally look on the 8% table because it's going to have different numbers on the rows than the 10% table. So 10% table, row 5, and we are doing a P/A, right? So P/A, we go back here. That's where the 3.7908 came from. 3.7908. So if you look at row 5, P/A, it's 3.7908. So that is the ratio of the present value to the annual amount. So think about that for just a minute. They're making 5 payments, but they're saying the ratio of the present value to the annual amount is only basically 3.8. So the time value of money, if we take a step back and think about the concepts, 1, 2, 3, 4, 5. Here's the five revenue amounts. The money at the end of this time period, this money in year 5, it's not worth very much in today's terms. And so obviously it's not going to be the present amount. If here is P isn't just going to be 5 times whatever A is. Because even though there's 1, 2, 3, 4, 5, it should be less than 5 times because the amount in the future isn't worth as much as money now. And so this is something that's called discounting. When you take money from the future and move it to the present. We've already been talking about compounding, which is the opposite of that. Compounding is when you take money from the present and you're pushing it into the future. And compounding makes money grow. But discounting makes money shrink. And that's why our ratio is less than 5. Even though there's 5 payments, the ratio is less than 5 because this column is telling you how much does the money discount. And so the 3.7908, that means the present value of all those payments is 3.7908. So if we go back to the solution here, 18,000. Everybody get this? Feeling good? So if you had a concept question on a quiz, like what is discounting, you'd say discounting is moving money from the future to the present. What is compounding? Compounding is moving money from the present into the future. Or it is the effect of interest being paid on interest. I want to show you another thing before you do the last problem. Problem 4 on the back, you have to know about the standard notation for an annual series and a future value. Now this is a little bit strange, but this is the way it is. Think about if you were getting money every year. What's shown on this cash flow diagram is you receive money every year, and then in the last year you have to make a payment. But the strange thing about it is you're making the payment in year 5, and that's the same time that you got revenue. And so the net effect of year 5 is probably going to be the payment is greater than the revenue, so it's going to be a net outflow. But even still, we assume that an annual series or a uniform series has nothing happening in year 0, but then it has an equal number of events that happen each year, and the terminal year is the same year as the future amount. So the same thing is true if we are converting between a known future amount and an unknown annual series. You'll notice that the known amount in year 5, and that's when we have to make a payment. Well, we have the revenue coming in year 5 as well. So there's nothing. The key things I want you to remember is there's nothing happening in year 0, and the F and the last A is in the same year. This one shown is just for year 5. Question? Okay. So if you haven't already, you can go ahead and get started on question 4. Oops, I wasn't supposed to show you the solution to that one yet. There you go. Question 4.